LLC at YCMU Nashik. Dear friends, for the first year we have basic science, in which uh, physics is one of the subjects which we have to pay more attention, and dear friends, elasticity is one of the topics which we have to discuss with more details. For this we have Professor Anil Kokadesa to talk about on this topic. He is HOD at Physics Science Department, MET Polytechnic Nashik. And dear friends, he is going to guide us on this topic. So let's welcome him. And sir, please continue with your session.
Okay, good morning, dear friends. Today we are going to discuss first session we are planning to cover elasticity. This one is the most important chapter for especially mechanical engineering and civil engineering students. In this chapter we are planning to cover, these are the different articles: concept of elasticity, plasticity and rigidity. Then we have to study what is the deforming force and what is the restoring force. Then we have to study what are the different factors those are affecting on the elasticity property. Then what is the stress and types of stresses we have to discuss. Then we have to discuss about the strain and types of strain. Then we will see what is the Hooke's law, which one is the most important law for the elasticity. Then we will see what is the modulus of elasticity. We will discuss different types of modulus of elasticity. Then after that we are going to discuss about the stress strain diagram, means how stress and strain both are varying mathematically and graphically. Then we will see on the basis of stress strain diagram or stress strain curve, we will discuss what is the yield point, what is the ultimate stress, what is the breaking stress, and what is the factor of safety. And after that we will discuss about the Poisson's ratio and compressibility, and then we are going to discuss few problems. Those are based on different mathematical equations coming in this chapter. Dear friends, first we know matter is basically classified into three types: solid, liquid and gaseous. Solid is a state of matter having definite shape and size. Liquid is also second state of matter in which shape and size can vary with respect to conditions, and gas is a third state of matter having no specific shape and size. In this chapter we have to study basic properties of solid state materials. Basically solid state materials are showing three important properties: elasticity, plasticity and rigidity. Now what is elasticity? Elasticity is a property of solid material in which when you apply external force on a body, then deformation of body takes place. Now deformation means what? Deformation means change in shape or size of a body, that is called as the deformation. That means when you stretch a rubber, then length of rubber increases, that is increase in length or decrease in length, increase in area or decrease in area, or change in volume of a body. That means when length, area or volume, such type of parameters are changing under external force, then one can say it is a deformation of a body. Then what is the elasticity? Elasticity is a property of a solid body in which when you apply external force, then dimensions, that means either length or area or volume, physical dimensions of body are changing, and when you remove the external force, then body regains its originality. That means when external force will be removed, then body is coming to its original position. This property is called as the elasticity. That is, elasticity is a property of a body in which body changes shape or size under external force, and it regains its original position when the external force is removed. This property is called as the elasticity. Then what are the examples of the materials those are showing the elasticity property? Rubber is one of the examples of the elasticity. Steel, copper, such type of materials are showing elasticity. That means when you apply external force on such type of materials, then deformation of the body takes place, and when you remove the external force, then body regains its original position. Therefore this property is called as the elasticity property, and those materials show such type of elasticity property. All these materials are known as a elastic materials. This one is the first basic property of the solid material. Then we have to discuss about the plasticity. Second property of solid is called the plasticity. In plasticity, when you apply external force on a body, then deformation of body takes place. That means body will show the change in their shape, or one can say size. Body shows the specific type of deformation, but when the external force is removed, then body cannot regain its original position. That means if you consider any plastic material, mud or clay, when you apply the external force, shape and size of body or shape or size of body changes, but body does not regain its original position after removing an external force. That means this property is called as the plasticity. Plasticity is a property of solid in which body changes shape or size under external force, but does not regain its original position after removing an external force. This property of a body is known as plasticity. And third one property is the rigidity. Rigidity is third property of solid in which external force is not affecting on a body. That means the body is not responding to the external force, and there is no change in shape and size of body takes place. Therefore such type of property is called as the rigidity. Means cement, concrete, stone, marble, these are the examples. Means if when you apply external force on such type of bodies, then there is no deformation, or shape or size of body does not changing, or such type of property is called as the rigidity. Means basically we have to study three important properties of solid: elasticity, plasticity and rigidity. In this chapter we are planning to study only the elastic property of a body, elasticity. Before starting or before going towards the main point, we have to study few important basic definitions. What is the deforming force and what is the restoring force? When you apply external force on any elastic body, then the body changes shape or size. That means physical dimensions of body are changing under external force, and that external force is known as the deforming force. That means I can say the external applied force on an elastic body which produces deformation of a body, that force is called as the deforming force. That a deforming force is the main force which is responsible for a change in shape or size of a body. Therefore deforming force can be defined as it is an external force applied on elastic body which produces deformation of an elastic body. Then you know, in case of elastic body, when you apply external force, deformation of body takes place, but when you remove the external force, body regains its originality. That means there is another one force which is intermolecular force, which is internal force in a body, which is restoring the body towards the mean position or original position. This is the internal force developed in a body. When you apply external force, deformation takes place, but when you remove the external force, there is the internal force inside a body which is developed, and that force is trying to regain, or that force is regaining the position of body towards its originality. That force is called as a restoring force. That means I can define restoring force is defined as it is an intermolecular force in an elastic body which restore or which regains original position of a body. That force is called as the restoring force. And you know, when you apply the external force, then deformation of body takes place, and internal force which is developed inside the body which restores original position. That means body is coming, if body is coming 100% at its original position, then I can say deforming force is equal to restoring force. That means in perfect elastic material, both the forces are equal. deforming force is equal to restoring force. That means whatever the amount of force which is required to deform the body, same amount of force is required to achieve the originality. Therefore, in perfect elastic body, both the forces are equal. Deforming force is equal to restoring force. Now, before going to discuss about the one can say nature of the elastic material, we have to see what are the different factors those are affecting on the elastic nature of a body. Temperature, annealing, hammering and rolling, addition of impurity and stress. These are the different factors affecting on the elastic nature of a body. We know in solid material there are arrangement of particles, or I can say grains. When you heat the body, that means if you increase the temperature of body, then expansion of grain size takes place, grain size increases, and due to increase in grain size, intermolecular distance also changes, and automatically elasticity of the body decreases. That means if you increase the temperature of body, elasticity decreases. Due to increase in temperature, grain size increases, and due to increase in grain size, I can say elasticity decreases. That means elasticity is inversely proportional to the temperature. Temperature is in a reverse way, it is affecting on the elasticity property. If you increase the temperature, then expansion of grain size, or one can say expansion of grains takes place, and due to increase in a grain size, one can say elasticity decreases. Smaller is the grain size, more is the elasticity. More is the grain size, smaller is the elasticity, or less is the elasticity. Therefore, temperature is inversely proportional to the elasticity property, or I can say elasticity is inversely proportional to the temperature. Second one is annealing. Annealing is a process which this is a thermal process in which temperature of a body increases up to certain limit, and cooling of body can be done gradually or can be done uniformly. Then this is called as annealing. In annealing also, when you perform the process of annealing on any elastic body, then due to annealing, that means annealing is the process in which temperature of a body we are increasing. Therefore, due to increase in temperature, again grain size increases, and due to increase in a grain size, elasticity decreases. That means annealing is also affecting in a reverse way on the elasticity property. That means elasticity is inversely proportional to the annealing process. Temperature is also inversely proportional to the elasticity. Annealing is also inversely proportional to the elasticity. That means if you carry the process of annealing on any elastic material, then its elasticity decreases. Then third one a factor which is affecting on the elasticity, hammering and rolling. That means in the process of hammering or rolling, particles are one can say separated, or particles can be divided into too many particles or too many grains. That means a single grain will be divided into two or more than two grains. That means grain size decreases due to hammering and rolling process. These are the physical process, and due to such type of processes, grain size decreases. And as you know, when the grain size decreases, then elasticity increases. In first two property, temperature and annealing, grain size is increasing due to temperature and annealing, and elasticity decreasing. But in this process of hammering and rolling, a single grain will be divided into two or more than two grains, and when the one can say grain, there are too many grains are produced due to such type of process, hammering and rolling. Finally, grain size of the body decreases, and due to decrease in grain size, elasticity increasing. That means hammering and rolling, these are the two processes increasing elasticity of a body. The next one, addition of impurity. That means when you add the impurity material into any elastic material, then what will be the net elasticity of material? As you know, if the added material into the elastic is more elastic than parent one, then elasticity increases. But if you add less elastic material into any elastic body, then elasticity decreases. That means final elasticity of any body is depending on the nature of impurity. If you add more elastic impurity into any elastic material, then elasticity increases. If you add less elastic material into any elastic body, then elasticity decreases. That means addition of impurity affects on the elasticity property, but I can say which depends on the nature of impurity. And if you apply stress, if you apply frequently or continuously stress on a material, stress is nothing but I can say external force applied on any elastic body. And if you apply frequently such type of forces on the elastic material, you know, due to such type of continuous application or due to frequent application of stress, elasticity of body decreases. That means if you observe, if you consider example of rubber, if you stretch the rubber for multiple times, then permanent elongation of rubber takes place. And permanent elongation of any elastic body means I can say elasticity of material or elasticity of the body is decreasing. That means these are the basically 5 factors affecting on the elasticity. Temperature, elasticity is inversely proportional to temperature, elasticity is inversely proportional to the annealing, elasticity is directly proportional to the process of hammering and rolling. Impurity, addition of impurity, that is elasticity property depends on the nature of elastic nature of impurity. If you add more elastic material into parent elastic material, then elasticity increases, and if you add less elastic material into any elastic body, then net elasticity decreases. And if you apply continuous stress or frequently, if you are applying stress on any elastic body, then permanent deformation of body takes place and elasticity decreases. These are the basic factors affecting on the elastic nature of a body. Then now we are going towards the stress. What is the next most important article? Concept of stress. When you apply external force on a body, this force is called as the deforming force. Deformation of elastic body takes place. Then how you can find stress? Stress is a force acting on a body. Stress is a force acting on a body which produces deformation, means which produces change in either shape or size of a body or both. That is I can define stress is a ratio of external applied force on a body to the area on which force is applied. That means I can say stress is equal to force divided by area. You can see this formula, stress is equal to force divided by area. That is stress is a one can say most important parameter in the elasticity. When you apply external force or deforming force on any body, then deformation of body takes place. Then whatever the external force applied on a body, that force divided by area on which force is applied, this ratio is called as a stress. Then as you know, deforming force is also equal to restoring force. Therefore I can define stress is equal to restoring force upon area. That means I can define stress is a ratio of restoring force of a body to its area. That means alternatively you can define this also. Therefore stress is a most important concept in the elasticity, and stress is defined as stress is a ratio of applied force to the area of a body, or external applied force per unit area of a body is also called as stress. Now what will the unit for stress? Stress is equal to force divided by area. You know, in a SI system, force is measured in a Newton and area is measured in meter square. Area is equal to length into breadth, or if you consider wire, then area equal to pi r square. Therefore you can say stress is equal to force is in Newton divided by area in meter square. Therefore Newton per meter square is the unit for stress, and therefore stress is most important concept in the elasticity, and it can be defined as it is the ratio of applied external force with area of a body, or stress is a external applied force per unit area of a body, or stress is a restoring force per unit area of a body. In this way you can define the stress and you can give the unit Newton per meter square. Now after definition of stress, we have to study the different types of stresses or types of stress. Basically, you know, when you apply the external force on a wire, then that means if you consider one elastic wire, one end of wire is fixed to the rigid support and second end is suppose loaded by external weight or external force. That means if you attach any mass to its another end, and if you keep this wire under suspension, then one can say due to due to gravitational force, that weight is trying to go towards Earth's surface. That means m is a mass, then m into g is called as the force acting on the wire. That is called as the weight. That means if you attach external mass to the one end of a wire and one is fixed to the rigid support, then what will happen? This wire is suppose of elastic material, either steel or copper. Then elongation of wire takes place. That means length of wire increases. If you consider example of wire, then length increases. If you consider the wire is in, the body is in the form of sheet having only length and breadth, and if you apply the force, then area changes.